will probably sit down because I have kind of a short demo to do after, but I also have a few slides to go through. So what I'm going to talk about is a problem of kind of navigating complexity and how to understand company architecture. This graph is not from FundyCircle. I just stole it from the Twitter account of Monzo. I don't know if you've seen the discussion about their internal architecture. And this is what their microservices talking each other look like. So it's quite beautiful and terrifying at the same time. So I thought it was kind of a good example of what we can talk about. So the problem is in general that when you have a microservices architecture with event-based or not, the hardest thing is to really figure out how things talk to each other and what are the connections between these things. And mostly, like for new starter, more importantly, it's quite hard to know. So this is why we kind of came up some time ago. The original idea was from one of my colleagues, something that could help us to actually visualize these Kafka topologies in this particular case, but it's kind of a more general idea of trying to auto-document and visualize more easily all the internal architecture of the company. So this is library which is called Topology Grapher for kind of a lack of a better name. We might find a better one soon. So it's actually open source since last week, so quite recent. It's also on closures, but not a stable version, just because there's kind of a problem in their build. But should be, you can already try it out if you want. So if you want to have a look, feel free to play around. A lot of documentation has to be written and stuff, but I'll show you how to use it now. So suppose we have this incredibly silly problem of taking a list of maps which contain like enable, true or false, and then a value. And you want to discard all the things where enabled is false and increment the value otherwise. So incredibly simple and silly, but kind of just to show a point. Using the Jackdaw libraries, also developed a FundyCircle, we can now define this Kafka topology which solves this problem in a way that is kind of readable enough and relatively easy to think about. So you have this function that takes a builder, like a topology builder, and then here you actually read from this topic input, create a case stream, and then you pipe it through, and first you filter out everything that is not enabled. You apply this map, you apply this function transform to the values, right? Transform is defined here, and then you write out another topic. So as you can see, this example is kind of very simple, but you can it's already not entirely trivial to see what's the input and what's the output. And of course, none of the actual real topologies are like this. They're way more complicated. So what this grapher allows to do is to automatically generate this kind of graphs, which there are two types now. So one type is simply showing you the input and the output, like in green, which are topics, and then the bit in the middle is the actual name of the topology. In the more detailed version, you actually see what are the intermediate steps that are happening. So you have a filter here, and then you apply a map value, and then eventually you write out to the output. So that's mostly kind of what this library is doing, really. I'm going to do a demo now to actually show you how to do it. In the project itself, we have now, open a demo file. There is now a pull request to the topology graphic project with a sample project which you can play around with. So it will be also merged there, and you can just do line REPL in that project, and everything will be fine. The important thing to mention, which is quite good to know, is that let me switch to the REPL, is that you don't need at any point to actually run a Kafka cluster or do anything with the real Kafka to be able to generate these graphs. Because the important discoveries, let's say, is that the actual representation of this topology just comes from a topology object in the Java library. So, and this topology object is really just an object which doesn't need any kind of anything to run at that point. And then eventually it will be taken by the Kafka and then it will be run, but that's something you don't need to care about. And that's also why it's so nice to kind of use this approach to just generate the graph in Circle CI and then just push it somewhere and then kind of analyze it later on or kind of aggregate it with some other graphs. So let's have a look at, so we have two files now. There's file describe CLJ here on the left, and then there is here like a demo CLJ. I don't know if you can read, maybe fine. So here I list a few topologies which I take from these other files, which are just the same things that I was showing in the slide before. And I just done two topologies with Jackdaw and one with pure Java interop, because it doesn't actually require Jackdaw. You can use whatever you want. It will work as long as you have a Java topology. Then there is a function here, renderAll, which just generates all the files, the graph files. So here, for example, I just evaluate these topologies. Then I define the sample topologies. Right, I didn't evaluate this. I define this sample topology to be this thing. Let me switch to this. And now, first of all, I will actually call something which kind of transform into a Loom graph this topology, which then allows you to do some more kind of querying of the actual data. Because the other big thing which we're trying to do eventually, which is not really there yet, but is to actually be able to query information like who reads this topic, who writes this topic. Yeah. So this just to transform, and then now if I want to extract the topics from the topology, I see that the inputs are this and the output this. And now for the more interesting part, if I just want to actually render everything, you will print out kind of under here the file where it's actually generating the graph. And if I open it, it is, yeah, this one. If I open it, this is kind of how it looks like. So there are three topologies, which are, two of them are kind of related, the third one is not. And this is in detail mode. And the other cool thing is that in this particular kind of sample project, I also have integration with Hawk, which means that whenever I change something, if I do this, comment this out a few things, and now I avert the buffer here. We do it again because we wrote it to another file. Maybe let me check because demo didn't never work. 14. Yeah, this one. Yeah, it was this one. So yeah, sorry. The problem is that there are two different modes here of defining the graphs. And here I have mode topics at the moment, but if I just change it to mode detail and I open the other file again, which was the one I was trying to open before. Yeah, so now you removed a couple of extra steps in here. So just let's go back to the slide, not much more time. The flow to actually generate all these things is just take a topology object, call the describe method on it, and then transform that thing into actually some EDN, which is a graph representation, which they can then use to do all this, generate actually the graphic code, which generates the actual image. What we do also is to dump it to disk and push it to S3. So then we have something else which takes all this data and visualize it in a UI. Yeah, and then the rendering is just done simply by using dot at the moment and grab it. The viewer looks something like this at the moment, which is not great, but it's not open source yet, so that might be a bit more difficult because it requires, it's kind of tied to our infrastructure at the moment. But in any case, it's not actually hard to do it yourself. The hardest part, this is actually an example of a real graph of one of our services. So these are kind of 8 topologies to get together, and they are all linked together. So the nice thing is that you can merge arbitrarily graphs across different services, and you get all this sort of information in one flow, kind of more easy to see and navigate. Lots more to do. Can have documentation, improving the query mechanism. We can add extra information from all different sources, Kafka Connect, schema register potentially, and live data also would be nice to add. That's all I want to say. Any questions or ideas, welcome. You can also kind of just write an issue there, or yeah, just let me know if you have any questions.
Thank you.